Assalamualaikum. I am Muhammad Muzakir bin Muhammad Razik from Set 2 of Dynamic and Process Control. This is an assignment for simulation using the Simulink. So I'm going to start with the transfer function. So we obtain these transfer function equations from the classification of material balance and transfer functions of the heavy equipment from distillation column. So from the whole equations, you are going to obtain the transfer functions, which is these two negative values and two positive values. Now going through the simulation part, which is starting from the servo control. So for the servo control, for the system of P controller, we are starting with the values of XD and XB of 20. So this is the design of the Simulink, and then this is the result in graphical form for the result of P controller. And then we are going through the system of PI controller. We are going to use the same values of XD and XB, which is 20, with the integral values of 0.3. So this is the result of the PI controller, and this is the summary of input for each controller, which is consists of the controller, proportional, the integral values, derivatives, set point xd and set point of xb. Now going through the next part, which is the regulatory control. So for the regulatory control, uh, we have the values for the whole process, which is uh, the the set is consists of the loads, which is the set to 10, which is with the same values of xd and xb is 20. So this is the result for P controller in a graphical form, and then we are going to go through the uh, pi result with load. uh, Pi result with load, we are going to have this graph, and then going through the PID controller, we are going to have this whole graph. And then these are the summary for all the values that is from the graph for the set point, from the set point and set point of xd and set point of xb, and also all the loads, which is all set to 10. So going through the next part, which is now we are going to set the controllers with multiple set points. So the first one is the system of regulatory control with the multiple set points. So this is the design, which is we add some multiple set point to the initial initial XD and XB. Uh, so from these values, we are going to set the time for the XD1, XD2, and XD3 as for 10, 20, and 30. So we are going to see the result from P controller. Uh, this is the graphical result of P controller using the multiple set points, and then going through the PI controller. This is going to be the results, and then the PID controller. We are going to obtain these results from the for the graphical. And these are the summaries for the input for each controller from P controller, PI controller, and also PID controller, which is all set to the same load, which is at 10. Now going through the other part, which is the multiple set points and loads. So we add another load for the system. So from the picture of 0.101 here, we can see the system of regulatory control with multiple set points and loads. So we add the loads here, which is uh, 4. As we can see from the before, it has no loads at all. Now we add the loads inside as for the addition for the other results. Now we can see the result for the P controller has changed, and the result of PI controller and also PID controller, which is all changed. And this is the summary of the results for each controller. Uh, for conclusion, based on these graphs, we can see that the PID controller is like the most stable out of all the graphs. So it is because that it combines the benefits from P and PI controller results. So the derivative value enhances the response, and it has more accuracy for the PID controller. Uh, so based on this controller, we can get that it has quick settling time, and also the feedback action reduce the vibrations, which is offering the smooth control. Now we are going through the other part, which is the Ziegler-Nicholas tuning. For Ziegler-Nicholas tuning, we are going to use the initial tuning initial system. So this is the drawing for the Simulink, and then we are going to obtain these two data, which is the top data for the P controller and also the bottom data for the P controller. It has a different value of starting point. And then we are going to have this summary of input for the Ziegler-Nicholas tuning. So from the both diagram, the delta P and PU, delta P is equals to PU, which is it is equal to 5. So from this value, we can obtain the value of GC, the KC, top 1 and top distillate. So these are the values that we are obtained from the Ziegler-Nicholas tuning system. Continuing that part, so we are going to set some parameters, which is these are the parameters that we are going to set. So like for the XD and XB, we are going to set the KC, which is at the same values, 16.02, and also the uh, top one at 4.265. So these are the data that we obtain. The first data is the PI controller using the Nicholas tuning system. So this is the PI controller, and this one is actually the PID controller. So this one is the PID controller data. So continuing the part, now we are going through the Cohen-Kuhn tuning. So for Cohen-Kuhn, it is actually an open loop model for tuning, because it is said that it is going to make a more significant settling time. So this is the simulation model, and then this is the outcome for top data, and this is the bottom data, and this is the summaries of the Cohen-Kuhn controller tuning. So we obtained the KC, the top one, and torque distillation. And continuing that part, we are going to have the Cohen-Kuhn tuning with the proportional value is set at 39.58. So this is the value that we obtain for P controller, and for the next part we are going to obtain the PI controller values, which is set at 30.2 proportional with the 2.073 at integral. So this is the PI data, and the last one is the PID outcome data. So we are going to set the proportional value at 43.23, the integral at 3.0351, and also 0.5088 derivative. So this is the data that we obtained for the PID controller. So that is it for the whole simulation assignment. Uh, Thank you.